This question is a system of equations. It's point of intersection. This is very standard algebra stuff. The SAT is going to have 2 or 3 of these every single test, so you got to know how to do this. I'm going to show you 2 ways to do it. I think that for most people, you're going to look at this and get a little scared because of the fractions, and that's okay. That's not a bad thing. We're going to use that fear to our advantage. So what I would notice is that I've got 1/2 y, and I can get rid of fractions. I can get back to basics, to more safe equations by using multiplication. So in this case, that first equation has fewer pieces. And so I would get rid of the 1/2 just by multiplying by 2, right? So in order to get rid of a fraction, you multiply by the reciprocal. The reciprocal of 1/2 is 2/1, okay? So that means I got to go to both pieces though, right? So it's not just that I'm affecting the front part that I don't like. It means I'm also going to have to affect the 4 at the end, which doesn't bother me, but is going to change. So right now, this equation is much simpler. Y is equal to 8. And this is perfect for substitution, which is the method we're going to use here, substitution. And basically what we want is we want either some sort of equation or number, and we need to plug it into the other equation. So y equals 8 is as simple of an equation as we can get here, and that lets us substitute for the y that's there. So now I can rewrite this equation as x minus 1/2 of 8, because y is equal to 8, is equal to 2. And just do some normal kind of simplifying here. 1/2 of 8 is 4, and then we add 4 to both sides to get that x is equal to 6, and that's what they want. So D is the answer, that's it. And that does not take very long, totally safe. The only shortcut that some people are insistent upon is doing a substitution before we get y equals, right? So on the SAT, a lot of times, we either don't want to or are unable to get an equation like y equals 8. We can't isolate a variable enough to get its value. And so sometimes we have to treat like chunks of variables or chunks of numbers as if they were just by themselves a variable. So what you might notice here is that 1/2 y is like a unit that also appears in the other equation. So what I did at first is I kind of simplified that and made y into a number, but the way substitution works is you can also substitute exact units into other places. So if you really wanted to, you could take this 1/2 y and substitute for the 1/2 y in the other equation, which means instead of taking 8 like we did before, now we take 4. And it gets substituted in for the entire piece in highlights, right? It's entirely, that 4 is equal to 1/2 y. So in this case, I would just end up with x minus 4 equals 2 because 4 is equal to 1/2 of y. And then we finish it up the same way. We add 4 to both sides and we get 6. That does not really save us any time here. I don't think that that's like somehow like the difference between an 800 and a 600. Like this is not that big of a deal. The reason I bring it up though is a lot of people get very excited when they see these things, so I just wanted to acknowledge it instead of getting a million comments about it. But more important, it does happen in other places where that little move is more efficient or is the only way you can solve things. So you do need to kind of be aware that this exists in the grand scheme of things for the SAT, because it might not matter here, but on another question, it might be the difference between an 800 and a 770. It could be that one last thing. So just something to keep in mind. Sometimes on the SAT, we're not substituting for, or not solving for a variable. We're substituting or working with chunks of variables and numbers, and we're keeping them as a group, and we're using the group as a group to make substitutions instead. It's a good skill for math in general.